Let's see question number 21. There are three particles A, B and C and situated at vertices of an equal triangle ABCF side L. At time t is equal to 0, each of the particle move with the constant speed u. A always has its velocity along a AB and B along a BC and C along a CA. Right? So this was the diagram, and there are particles A, B and C, and each one is moving with velocities of u. So this A is having a velocity u, B is also having velocity u, C is also having a velocity u. So eventually if ఒకదాని బ్యాక్ సైడ్ ఒకరు మూవ్ అవుతూ ఉంటే this velocities will change, like the direction of this velocity will change like this, and A direction will change like this, as well as this B direction will change like this, and therefore the size of the triangle will reduces, and that will be reduces to like, so this will be reduces to like this, so that will be reduces to like that. And let's say now this L distance will become a x, as well as x here, as well as x here. So this will be the point A, and this will be the point B, and this will be the point C. So you know this angle is 60 degrees, right? And every angle is a 60, 60 and a 60, 60 as well as 60 and a 60, and thereafter they will eventually, this triangle will decreases, that will decrease and decrease and decrease, and these particles will meet exactly at the centroid like this. So they will meet at the centroid like that, exact ga ee triangle, bigger triangle edaithe undo then centroid దగ్గర meet అవుతాయి. Therefore this B is total, this B is moving a total distance of what? This B is moving a total distance of, let me draw here. So for example, if it is going to meet here, so this is traveling this much of distance, this one, it is traveling this much of distance, or here this B is traveling this much of distance, or so that is going to be displacement of what? That is going to be displacement of a B. So let this displacement is let it be like a S bar, and if you draw, sorry, so if I draw it a perpendicular to on this line BC, so this is going to be like L by 2, and this angle is how much? E angle at that is 30 degrees. Therefore I wanna wish to find out this displacement. So that's my logic number 1, right? I gonna find out the displacement, so that is might be my logic number 1. So let's say I gonna find out displacement. So this displacement can be written as, I can write this cos 30. If I write this cos 30 equal to what? Cos 30 is equal to L by 2 into I have a S bar. Therefore S bar is equal to L by 2 cos 30. Cos 30 can be written as a root 3 by 2. So this 2 get cancelled. Therefore displacement S bar is equal to, how much is it? That is L by root 3. The displacement is equal to L by root 3. So that's the logic number 1. And coming to the logic number 2. So if you have a look on this green triangle, that inner triangle, so that seems like, so I'm just drawing this green triangle like this. Is a green triangle anukondi. So let's say E point A, sorry, this point is B, this point is C, and this point is what? This point is A, and this B is moving towards C with the velocity of u, and C is also moving with the velocity of u along this A. So let's say this angle is how much? This angle is 60 degrees. If I wish to find velocity of C with respect to B, if I want to find velocity of a C with respect to B, then we could say that, so this one, this can be written as, or else instead of taking a velocity of C with respect to B, or take it as a velocity of C with respect to B, okay, let's solve it. So this can be written as so this is a point C, and this is a component of C in the direction of this B, which is nothing but how much? U cos 60 degrees, and I'm saying velocity of C with respect to B. So nothing but I have to reverse the direction of B velocity, and I have to add to C. If I do that, that will be in the same direction as u cos 60, that is the velocity of c with respect to b. Therefore now the c is approaching b with the velocity of how much? The c is approaching this b with the velocity, therefore velocity of approach of c towards a b will be equal to u cos 60, which is u by 2 plus, you could say it is nothing but a u, that will be equal to 3u by 2. So that is the velocity of approach between a c and a b, that is the c is approaching a b with this velocity, that is nothing but a velocity of approach, which is velocity of approach. And velocity of approach can be written as a dx by dt, right? Because of this approach will change that position between this b and a c, will be equal to 3u by 2, right? So if I just do the integration part, allow integral of dx will be equal to integral of 3u by 2 into dt. So initially this length is how much? L. Finally that is becoming a 0. Allow a 0 here, allow a t here, right? If I do that calculation, how much will I get? Let's see how much we're gonna get if we do that calculation. That's gonna be how much? So lava this L is equal to, we have a 3u by 2 into t, therefore time t is equal to 2l by 3 into u, right? So that's a time. That was the time, the time after which they will meet is 2l by 3u, therefore this answer is right? That is a time, that was the time 2l by 3u. And what else we have to find? We have to find total distance traveled by each particle before they meet is. So what is the total distance traveled? The total distance traveled will be like, so you know that each and every body is moving with velocity u, constant speed. Therefore distance can be written as, therefore distance is equal to, you can write the distance equal to like that, or you can write, so I'm writing this velocity or speed as a u, so u into time. So therefore distance is equal to, u is a u only, into 2l by 3u. Therefore this u get cancelled, therefore d is equal to 2l by 3, right? That is the distance. That was the distance is equal to 2l by 3. And what else we have to find? Again we have to find average velocity during the motion. So average velocity during the motion is nothing but I find already displacement is how much? L by root 3, and I know the time, total time. Therefore therefore V average, or average velocity, is equal to total displacement by total time. Total displacement I get it as a L by root 3 into total time. What is the total time we get? 3u by 2, right? 3u by 2, sorry, time is not 3u by 2. What is the time? Time is 2l by 3u. So LL get cancelled, that will be equal to this one cancel, root 3 by 2 into u, right? So that is the average velocity. And already we find out this one, right? So that is what the relative velocity of approach between our two particles. We already find this, that will be equal to how much? Velocity of approach, which is nothing but 3u by 2. Therefore for these questions, answers for this question, what are the answers? That is, first option is right, second option is also right, third option is also right, as well as the D also right. So all the answers are correct. Clear? So that's answer for this one, right? So this is one answer, and this is one more answer, that is this approaching velocity, and this is the time, right? And this is the displacement.